Hello, my name is Aldo Gómez and I am a student of Tec de Monterrey. I am going to talk about my key activity that is related to the Curie point. Talking about the justification. I chose this topic because I like chemistry and I am very interested in how the composition of a material affects how it relates to others, and also this topic is very related to physics. If we talk about the magnetic properties that are taken in account in the Curie point, the possible loss of magnetization could put in risk people's life that work in the different industries that work widely with magnets, like in the construction of trains, in cars, or in military instruments. So this investigation has the purpose of safer procedures in different industries that involve mechanical movement and avoid dangerous situations. Now, the research question is, how does the temperature variation affect the ferromagnetic properties of a nickel and steel coins when heat is applied? The properties of ferromagnetic materials are based on the exchange interactions, which are situations where the electrons intervene with chemical and physical reactions. The moment is the case when the electrons of a ferromagnetic material are aligned in the same directions, causing a magnetization of a field. But with the application of heat in the ferromagnetic materials like our iron, nickel, cobalt, or others, it's possible to cancel these ferromagnetic properties reaching a certain temperature. This is explained in the Curie law that was discovered by Pierre Curie, where M is the magnetization in amperes meter, B is the magnetic field density in Teslas, T is the temperature in Kelvins, and C is the Curie constant that is different in each material. It's important to know the Curie temperature of the different materials which we are going to measure, that are nickel and steel. In the case of nickel, its Curie point it's around the 353 Celsius, and in the case of steel, it arises to 770 Celsius. We can see in this graph that the magnetization in a material is decreasing in order the temperature is increasing. Talking about the variable identification, we have independent and dependent variables. The independent one is the temperature in Celsius, which is closely related to the time that the coin is space of the fire, because the more time the coin is in the flame, the more temperature it will have the coin. And the dependent one is the ferromagnetic properties of the coin, because they are going to be affected by the temperature. Now, we need to have some conditions to have our experiment fair. So the control variables are the same initial temperature applied, that are 0 grades in Celsius, the same time of heat applied, 1 minute, the same instrument to apply heat, a candle, the same magnet using the pendulum, and the same instrument to measure heat, that is the pyrometer. As a note, the pyrometer is an industrial thermometer that allows us to measure the temperature of some objects without the necessity of touch them. Now the experimental design. This experiment consists of seeing how an increase in temperature affects the ferromagnetic properties of a certain metal. And to have a broader point of view, we are going to experiment with two metals that in this case are steel and nickel. And it's expected at least 2 trials for each coin. To use the pyrometer, it's only necessary to press the trigger and focus the laser on the object that you want to measure. Here we have two pictures that are the prototypes of our experiment. If we need to replicate it, it will be necessary to do it in this form. To replicate the experiment are necessary some materials. In both experiments are necessary a pyrometer, that in this case is a radiogram pyrometer, a small slice of wood as support, a metal of clothes hook, a typical candle, and a fine copper wire. The only difference between the experiments are is the coin used, because in the nickel coin experiment it's necessary to use an 1 euros coin, and in the steel coin experiment it's necessary a 5 Mexican pesos coin. For the last, don't forget that it's necessary to sand the copper wire before exposing it to heat, because if it remains with the varnish that is colored, probably it can expose toxic gases. And as it was said, to use the pyrometer, it's only necessary to press the trigger and focus the object that you want to measure. In this moment will be presented a video of the experiment that is precisely the second nickel coin attempt, and it proves the loss of ferromagnetic properties during our experiment. And also here is an image of the pyrometer during the test, measuring the temperature. Here is the exact moment when it occurs. Here are the results obtained in the experiment, showing the graphs of each attempt, showing the different charts where the time and temperature are. As we can see, the temperature is increasing as time goes, and it's around a minute the time that was taken. According to the data obtained, it was possible to understand more of the experiment and interpreting the information. For example, according to the results, the temperature have increased in a linear form that is represented by y, that is equal to mx plus n. The time given also was enough to the reduction of nickel properties that, according to what it was seen, it would lose its ferromagnetic properties around the 110 to 120 Celsius degrees, and also the ferromagnetic properties of a metal that was nickel were reduced because of continuous and progressive presence of heat. That this wasn't seen equally in the case of steel, but it was expected because the Curie point in this metal is higher. But according to nickel, the time was enough to the reduction of its properties, converse of the results we expected. According to the data collected, the hypothesis is right because the ferromagnetic properties of the metal, that in this case is nickel, were reduced by the continuous presence of heat, as theory says. Also, with observation, it was possible to verify that the experiment complies with established mathematical models, and equally with another document experiments in the internet, where the nickel reduced its ferromagnetic properties around the 50 seconds in the fire. The only thing that does not completely fit is the temperature at which the nickel loses its ferromagnetic properties, because according to the theoretical models, it should lose it around the uh, 350 Celsius degrees, while empirically in this experiment, it have occurred in the 50 to 55 seconds, showing the pyrometer at temperature about 110 to 120 Celsius degrees. We're in the final part of this project, and we're going to talk about the main limitations and improvement proposals. There were some limitations during the experiment. For example, the type of the magnets that were in a sphere shape was really a problem. Keeping them without motion was extremely complicated during the experiment, and it cost a lot of time. Also, it is possible that the pyrometer malfunction, as because the nickel Curie temperature was not as the documented one. And there was no way to see if it was working properly. And to improve this experiment, it will be necessary to verify that the pyrometer works correctly, comparing its measurements with another pyrometer. And also, it would be very useful to have a cube magnets to be able to place them easily. This is the bibliography consulted or the references, and thank you for your attention.